who is to join? I think.
Ibrahim, he's coming. So, Professor, it's always going to be the same Zoom link?
Yeah, this should be the one, I think.
Okay. Yeah, sorry for that. We were waiting. I thought it was a new link this week.
Yeah, I think this is the one.
Good evening, Professor.
Hi.
Hi.
All right. So Ibrahim, you may turn on the video so you can see. Yeah. All right. So I think I see. So we have talked about the last week. 2 weeks ago. And, so if we need, I think we can change this to the weekly meeting. So let's see. Let's see. The what we talked about before was meeting summary. I think we can just turn on. Yeah, that's in a functional block diagram and software mobile applications and Linux installation. Think about more what is innovation and Raspberry Pi and task. Yeah. Okay. So this is the All right. So let me hear what you have done on this and others. Oftentimes I think I see that the students are not really up to the work, and just before the presentation they just get together. That shouldn't be the case, right? So you gotta otherwise.
No, so we usually meet two, 3 times a week and discuss other stuff.
Yeah, I will. Yeah, so let me hear. Why don't you share the PowerPoint file and individually you for individual who create. I think so basically everybody before this meeting everybody report or summarize maybe a couple of pages. Not just one line and a report, right? Not just one line, but I think maybe detail as much as possible. So detail report to the, let's say manager. Who is the manager now?
I am.
Yeah, okay, Mohammed. So everybody give your part, like 2 or 3 pages of a PowerPoint file detailed what you have done and what you encountered, what is the problem, and then the Mohammed, including yours, you just compiled it. It could be like 10 pages and something in that order. And so everybody, in turn, you present your thing, right? And toward the end, you summarize, and that's for setting for the next 2 weeks.
So basically, you want like a report from everybody, like 2-3 pages at least, or 2-3 slides at least, right?
Yeah, so it's not necessarily fixed format of 2 to 3 pages, but I assume
like enough
that
information, yeah.
Yeah, really study hard. 2 pages, you could fill out like 10 pages easily. So
easily, yeah.
Spend time, and so let's say you visit the GitHub, you download it and you installed and you tested it.
Right.
Now I think everybody should have a Raspberry Pi, and then you should have downloaded Linux, and then you install the OpenCV, and you should have run it already, right? You gotta, I don't know. So let me hear. By the way, so this title doesn't look good. You are not designing PCB. That's not a whole. The PCB is just part of the hardware, to support your application. Basically, we are developing a home automation controller, let's say, or a smart home automation controller, or home automation smart controller, or something like that. That is the overall title, and just one component of it, right? It's not.
Okay.
It's not designing PCB. No, it doesn't have any character in it, and so I like to put like a smart home controller, or smart home manager or smart home something, right? And so to discuss yourself and get rid of design PCB, get rid of it.
Mm-hmm.
The
Okay.
home, it is a home. It's about the home, and it's about intelligent control.
Right.
Yeah, so that's you don't need to even say the automation. So intelligent is already include like a AI based controller, right? So home intelligent or whatever, I guess, intelligent manager or home homekeeper or home whatever homemaker, intelligent homemaker or something. So it's just some interesting title, right?
Okay, we'll work on that. Yeah. Okay.
So you guys need to brainstorm and discuss and
Right.
make the effort on this, right? Okay,
Yeah.
so
Yeah.
that's the title.
Uh,
Okay,
yeah, I think we did a good amount of research the last 2 weeks. We can definitely talk more about that. So the functional diagram that you wanted to see,
yeah,
so it's centered around the PCB board that we're going to have, but we can start on this end. So we're going to have a software component to it, which we're going to use an Android phone for because on Android, it's easier to have an app go through the marketplace, whereas in iOS, you need like approval from the marketplace and you need to verify some factors. So that's why we're using Android devices there. Also, the application that we're going to use to make it, or like the interface, is called MIT App Inventor, and that is more suited towards Android, which is like another reason we're using that. So our mobile phone device, we're going to create an application for it through that MIT App Inventor version 2 that we found online through various research. From there, we're going to have that connected to a Raspberry Pi with Home Assistant server. So that Home Assistant server is something that Hassan was able to, and he can speak more about that. Hassan was able to download onto his machine through VirtualBox, and he has a Linux environment set up for that. Hassan, do you want to talk about that before we move on a little?
Yeah, sure, no problem. Yeah, so
okay, so why don't you just give the overall picture first, right? And then
Okay.
you go into
okay, I'll do that. Yeah.
Okay.
Okay. So okay, I start from my left side. I think so you guys the right side.
Relays?
Yeah, so relays from the relays because the PCB board start from here. So our PCB board contains like 4 relays.
by the way, so the
relays will be
PC board, so look, so Raspberry Pi is the computer, right? Computer,
Yes.
and
Right.
this should be the controller. This should be the controller. And I see that that should be the central controller, and then it has to connect, and then it's if you develop this PCB, I think that's going to be like a daughter board or something, right? That actually control or actuator sensor, right? Through this PCB, or even Raspberry Pi have a lot of GPIO, right? IO pins. So actually the control can be done using the GPIO, the interface, and then interface signal is very weak so that it cannot really, on and off or light or control the, drive the motor. So you need a power, and then you need a, separate the PCB board and so on, right? So I like to see the reconfigure this, right? So the Raspberry Pi, this is a computer thing. And this from the computer, then you have a next parallel to it, you have maybe that's a PCB, or you may name it, as you say, home automated controller or sensor actuator, maybe actuator and sensor, right? So that's what it actually do. And then also I like to see that the relay 1, 2, 3, 4, what is a possible, the device that actuated by this relay, turn on and off, right? So what you're gonna do in this relay 1, 2, 3, 4, right? With
Okay.
light or whatever, right?
Yes.
Or door opener motor, and the fan and type of thing, right? Whether it's on-off relay or like adjustable speed can be on-off, but it could be sliding thing from the 0 to like 20 revolution per second, so something, right? 1, 2, 3, 4. So I like to see more to the relay box. So if it's a too cluttered, I think you may want to just name some things of relay box relay or something. And then from the next page, I guess you may want to just explore more, expand more. So basically, like to again, let me say that a Raspberry Pi is you may just say Raspberry Pi is just one product that you're gonna use.
Yes.
Maybe central, like a main controller, and the main is the main. I don't know, maybe main controller, and then there is I don't know what is a good name, peripheral controller. It could be the instead of a PCB for home automation controller, maybe that's not definitely the intelligence is not in the PCB. Intelligence is in the Pi, right? The computer, the program software and everything is there. And then this PCB board is just connecting whatever the command coming out from the Pi and deliver this action to the real peripheral devices, or from the sensor information that is collected by this let's say PCB at the moment, and then from that PCB you deliver this information to the Pi, so that the software can program properly to responsive to the environmental changes and so on, right? So that's I see. So the smart intelligence here and interface, basically is an interface and interface of the intelligent cyber, and this interface in between, and this interface to the right hand side, that's either sensor or actuators, right? So these are the general category of it: computing intelligence and interfaces, PCB interface controller, and then the real space like sensor and actuators. So these are the main, I think, a component. And on the other side, as you rightly is nicely put, is a mobile phone, and that could be the display device or alerting device, or it's so different way. And then I see that the display is there as well. So in order to derive display current, that cannot be driven by the Raspberry Pi because the power, the current level is high enough to drive this LED display. So in order to derive that one, you have to the mains power, so that the PCB, the hardware interface can connect that part, right? So you understand it, right? So basically,
yeah, we understand the main voltage
okay,
and stuff. Yeah.
So that's a like 4 major blocks that contain everything, right?
Right.
If needed, I think you may want to in the 2-step block diagram. First, large like a central controller, parallel PCB interface, and then actuators, sensors, and mobile phones, and the display type of thing. So, and then that's the first very high level functional block diagram, and then the next level you feel more expanded blocks for each component, right?
Okay, like sub levels, right? Okay, yeah.
Yeah, go ahead.
Professor Lee, the 4 major blocks you said, it was relays, sensors, the PCB board, and the Raspberry Pi. That's the 4.
Well, the name could be different, right? So
right.
Say it again. So you may want to jot down.
Yeah.
So there's a main CPU CPU, right? Computer.
Mm-hmm.
This is the main computer, right?
Okay.
The computer, it happens to be Pi, Raspberry Pi. That's a computer, central node, which has the intelligence, right? And then next to it, you have, interface, because the Raspberry Pi cannot directly, read and write to the actuators, because I don't know yet what kind of actuators do you need, the power fan controller or valve controller, door openers. These are the actuators, and also sensors, light, humidity, sound, temperature, whatever the sensor. You have a sensor, array of sensors and actuators. That's the physical space. When we call, if I give you a little bit of what's going on in the world now, is a cyber. We call it cyber physical space, right? For cyber is the digital domain. And physical space is sensors and actuators, real deal with the real world. So the cyber and then physical. In between, that's the interface that connects the cyber, like a digital, and the real world behavior. I think that is the interface. I see the PCB home automation, that is sort of interface. Right, and so then this Raspberry Pi is a controller, but human interface. There should be a human interface, right? Computer human interface. So HCI, right? Computer human interface. That could, mobile phone could be, doing that, right? So how do you control the Raspberry Pi and all the other things? So how do you want to turn on the like a door, or how do you turn down the humidifier, or how do you turn up the temperature of the room? And those things you will control using this cell phone, right?
Yes.
Yeah, and then the response, the sensor reading. Okay, so current temperature, how do you read it? You're going to read through a mobile phone, or you may want to display on the OLED display. The display. So basically, it's idea of intelligence interface and the physical, the actuators and sensors, and human computer interface. This could be the display and the mobile phone, right? So basically, I think those are the main functional blocks.
Okay.
Okay. So I see that now already you have a relay. This could be the actuator group. You may say actuator group, and then also you have a sensors here.
Yes, please.
So these two are connected as it is correct. I mean, it's connected to the let's say hardware interface. May say the hardware interface.
Yes, please.
And then as big as this current PCB in the middle, you may want to blow up the assistant server, home manager or home manager server or whatever. That's a big item, right?
Right.
TT is the protocol that handles these IoT devices, right?
Yep.
It's efficient, energy efficient, and simple protocol, simple line of coding that can control the status and control the sensors and so on. Yeah, I think in general, I think this block diagram is fine, except that redefine, and also a little bit of rearrange, so that what I say. All right, is it clear?
Yeah, that's clear. Yeah.
Okay, good. Yeah, go ahead. So next time, I'd like to see this one redrawn.
Yeah, we will improve that or block.
All right. Yeah, but of course, if you have a opinion, surely go ahead and we can discuss. It's not just following what I'm saying.
Oh yeah. We need. Okay.
Go ahead. Yeah.
So I mean, yeah, for our interface, I do believe it's going to be the mobile application, and that's where we're controlling it. For the relays, I don't think we know exactly what we want to target yet. That's why we didn't put something like lights or something. I think first we're more so concerned about having like a prototype, and then we can worry about what we're going to change. Right, guys? Or
Yeah.
should we? Yeah.
I think that's possible, yes, at the moment. But I think, maybe there are some fundamental things. Like, to control the home, HVAC, right? In general, it's
Mhm.
HVAC. HVAC, you need to read the temperature.
Right.
You need to read, I think, humidity. Or
Okay.
you need to read the light conditions. If it's a so light, right? Turn off whatever light and so on. So at least there's maybe, as you put here, the sensor, several sensors. And depending on the sensor, to increase the temperature, you need to turn on the thermometer, right? So thermometer should be one relay.
Right. Okay, that makes sense.
What else, and also if you want to make this curtain automatically moving, up and down, then it's another actuator. What else? Like a door open and door shut, that's another actuator. It depend, or if you have a humidifier in the home and just turn on and off or something. And also even after turning on off, as I mentioned, whether you want to set the 30% humidity or even temperature 70 degree or 65 degrees. So there are two levels of control, right?
Yeah, I mean, that definitely makes a lot of sense because we
Yep.
need to have appropriate sensors depending on our relay. So we need to think about that first, and then we can design it. Okay.
Yeah, yeah.
That makes
And
sense.
that is needed because I think if you look at this like a warning signal, right? And it takes a lot of current. So you need to know the current rating, right? It's whether it's a 5 ampere or 500 milliampere or some, so that you design this the hardware interface. Let me just say hardware interface, HDI, let's say, or whatever hardware interface. So you can properly put the proper whatchamacallit IC, right, or transistor to turn and off.
Right. We are planning to do more than 15 amps or about 15 amps. So we
Yeah,
can use
so-
like heavy device, heavy electronics. So yeah.
Yeah, so that's I think you divide the work among yourselves, and you divide you take care of the humidity sensor, and then you just read the specification. So how much you need, how much current you need, individual members. Okay, and together we need 2 ampere or something. That's too
Right.
heavy, but that type of thing. So do you need the 5 volt? Do you need 7 volt? Do you need the 3 volt? How you wanna make this make this all work?
Right. Right. That's
That's where you need to divide the work and and harmonize all different requirements, and you list out the how the common specification should be.
right.
Okay.
Okay. I think we can move on from this slide.
Yeah, sure.
Did you guys want to say anything else about this slide?
What about?
Uh,
Yeah, I think so you talk about, so let me just quickly look at, so you have a display, you have a hardware interface, you have a sensors and actuators, and MQTT is just protocol, and yeah, there's a power supply. Power supply is not only to the PCB, but also it has to go to the Raspberry Pi, of course, right?
yes.
Oh
And,
yeah. Yes,
yeah.
yes.
And the home assistant in a web browser. So web browser could be sitting within the mobile phone, right?
Yes. Yes.
Or do you want to put some keyboard control in addition to the mobile phone? So if you put the display, and do you want to put some keyboard there?
Might have physical buttons there.
Keyboard, screen,
Physical buttons for
keyboard.
just for emergency. So and then for safety reasons. So yeah, we might have physical buttons. Yeah. Let's.
Can
Okay. Okay. So so how do you vision this? So you have a screen and you have a buttons, or on the screen, you can make the screen keyboard as well, right?
Yeah. It's OLED is
Inside the screen, touch
yeah,
screen.
touch screen.
You
Yeah.
can put, yeah. I think touch screen is making more sense these
Yeah,
days.
makes more sense, right?
Yeah. Instead of a separate, button that's a bulky and hard to design.
We'll think about it. So yeah.
I
Yeah,
think
yeah.
that's also more expensive, right?
Yeah, we have.
I think
Yeah,
so. Yeah.
we have to think about
Which
it.
one?
So,
I mean,
yeah.
the
Yeah.
touch sensitive display.
Yeah.
Yeah,
I don't know. You guys need to investigate how.
Yeah. I mean, we also wanted to talk about our budget today.
Okay.
But, yeah. Guys, did you have anything you wanted to add for this slide, the diagram?
I mean, it's nothing else to add here. If we can like add like a touchscreen in the Raspberry Pi, and we can control from there, it would be, you can do that.
So
I mean,
either from the mobile app, right?
yeah,
Or from the wall, because when
from the
you're
wall.
at home, you can just push to temperature setting or something.
Yes.
Or if you sit back in the couch and then you just use the cell phone and do the things.
Yeah.
Yeah. Okay.
So we're good this year.
You want to talk about this, Ibrahim? Or anyone?
Wasim, you can
I
go
can talk
ahead.
about it.
If you don't
Okay.
mind.
Yeah, I think last time you asked us about the innovation and the need of the project. So just to reiterate about that a little, so this is going to be more cost effective because currently all of these pieces and then put together are not something available on the market, and it's not going to be and it's not going to be vendor locked because like there's no current company, or like again it's not really on the market, so we are kind of hitting something that's not there and making it. There's going to be energy management because with all automation or something, it should intuitively be able to control how much it's turned on or off, so you're able to save some type of electricity usage in that sense. And then connectivity, this is going to be all around connected, which again isn't something that's currently offered on the market. You would be able to buy individual parts. And then the luxury of it. So this
Why?
is
What is the luxury of it?
Sitting on the couch, just pressing from your screen. So that's a luxury, that,
Okay.
right?
All right. Not so luxury. I mean, it's okay. Yeah.
Yeah, in a sense,
Yeah. Yeah.
yeah, and then
Okay.
like the overall use of it is to make people's lives easier, and this could be targeted towards the elderly or more disabled people where these tasks are done for them intuitively rather than them having to know that like for instance the AC, it could intuitively be changed and they'll save money that way rather than having to think I should turn down the temperature or I should do this and that, so it can work for them as well.
So I think when you are dealing with this senior person, then I think you need to be more careful more in designing the interface. It's easy to use, right?
Yeah,
because senior people is oftentimes left behind because it's so complex, how to configure and all those, right? Easy. So I think one of the things is you didn't say easy. Let's say easy to use.
Yeah, I mean, yeah.
Very
So
simple to use, so that the senior people, the large font size, not so many, complex configuration. So it's just out of box, it works right away. Things like that. Or
Right.
easy to use, or
Yeah,
simple
right,
to use, or it's especially for the elderly person, simple to use or something,
Yeah.
That could be the innovation.
It's not only for old people, so it's just for regular people that who know about little bit about electronics too. So let's say they want to add, the home automation to their homes too. So it's for people who know about electronics. They want to play with electronics too. So it's for them too.
Yeah. Okay.
So the software aspect of it that we talked about briefly. So we're going to use the MIT Inventor app for Android. So we can use MQTT, which can be controlled both
Via.
on Apple and Android. Yeah, via. But again, we're only targeting Android for now because they have less restrictions on their App Store marketplace.
Maybe, yeah. Okay.
Research Linux for mobile software application.
Yeah, that's what
So
you
yeah,
asked us for. We did research. Like Hassan did the research. So he installed the Home Assistant through VirtualBox, and there's Linux based system, and then we added ESP Home onto the Home Assistant, so to control the
What
device.
is, by the way, ESP stand for?
ESP ESP, they also make chips, and also they are it's like a software tool for home automation, a home assistant that helps with that. So
Okay.
Hassan, you know more about ESP, if you don't mind explaining.
Well, okay. So about the ESP Home.
Yeah.
So ESP Home is like this, like the add-on software for Linux, or for like Home Assistant. This is the add-on software. We can use this ESP Home and add that like attributes. Add attributes like you say, like a fan, lights,
Fan, bulb,
and then
HVAC.
and HVAC, like a humidifier, and then
Yeah.
AC, refrigerator. You can add them there, and then from there we need to write a software for that. We need to write a code for that, and then to run this thing. So from there we can we can we can control our relays, or you say like the executors from the, like yeah, we can control there from using our Home Assistant by a computer, and also by a Raspberry Pi. We can also download the Home Assistant Raspberry Pi.
Yeah, does that make sense, Professor?
I think, yeah, I so, yeah.
I think ESP stands for Electronic Stability Program, which is all related to electronic stability control. And there's like a stability, vehicle stability, dynamic stability control.
So
Yeah.
stability means that temperature can be maintained, and right.
Maintain, yep. Like, yeah.
Okay.
The
I see.
temperature. Mhm.
So this Home Assistant, there's a library there.
Yeah, I mean, just to if you want, I can share with the screen. If you want to see these things.
Yeah, surely. Yeah.
Okay.
Thank you.
You're welcome. I'll give me.
Yeah, Hassan installed, and he helped us to install our own computer, and he has done research.
Okay, good.
And VirtualBox is quite amazing.
Yeah. Good.
Yeah. I believe it's Linux. It runs on Linux.
Yeah, I think almost all the libraries are now these days in Linux.
Yeah, so you can see my screen, right?
Yeah.
Right.
Okay. So this is the interface of Home Assistant. So by the way, this is the Linux machine. So we need to go from here to go to Google, and then we need to just Home Assistant. Okay, hold on. 6, 8. What's going on?
Okay, take your time.
Is that your Gmail? Because I think we use a different one when I email you.
No.
347476.
I think I am missing this thing, the IP number. Yeah, 64.
I think the port number is 8123.
Yeah, 8123. Yeah.
Yeah.
Okay. Why is that? Okay.
Try to see like if your password is right.
Password is good. Password is good.
Why don't you stop screen sharing so you can see what the password
Yeah,
says?
you could exactly just stop.
Yeah, you may want to just try it. Yeah, and then share.
Okay,
Yeah.
Professor. Yeah, I'll do that. Okay.
So it looks like a package, right? And
Like
then
like
the job is to connect this. You define the peripheral, right? And control and read and write to device something, I guess.
Right, it gives you options of what you want to connect, and you're able to kind of send out commands.
Okay. So does it use the MQTT protocol?
Hassan?
Yes, Professor, we have
Yes,
to,
Professor. Yeah.
Yeah, it looks like it. Yeah.
ESP use MQTT, so yeah.
Okay.
We also showed that in the block diagram, by the way.
So next time, I think, for example, that you.
Yeah, we will. I think right now he's having technical difficulties, so next time we can show you.
Yeah.
So next time,
I can.
yeah, what I'm saying is that next time, because you already, for example,
Yeah, we kind of losing
Hassan
time.
has been working on this, home automation system, and
Yes.
you, explained a little bit, like a high level,
Right.
the.
And also, I think
diagrams.
the Wasim and Ibrahim was having trouble because they have like Mac, so Apple, so they were having trouble loading up the Home Assistant, VirtualBox, right?
Yeah, I actually downloaded the Home Assistant on virtual machine, so it doesn't really run. So I'm trying to figure out like how it's gonna go, but I've been trying so many times. Still, it doesn't.
Yeah, it works for
doesn't
Windows, but not for Mac. So they were
So
yeah.
I think you may rely on like a GitHub type of a high level, that is very good help out there in the community, and you can just post your questions. I think normally, I don't know which bulletin they are using, but these days a lot of people in the same community is eagerly to help you out.
Okay, yeah, we are working on it, so
Okay,
we'll figure it out and let you know. Yeah.
Hassan, no luck.
Why do you put the change from the Arduino to Raspberry Pi question mark? What is it?
We just wanted to make sure that we address from last time, like you said, use Raspberry Pi instead of Arduino. We're not using any Arduino, by the way.
Okay.
Yeah.
So I thought that you guys talk about that.
And
All
we will only use Raspberry Pi if we need to present the project in person at college. Otherwise, if we have to present from Zoom, we can do it through our computers. That's why we need the Raspberry Pi. You understand?
I don't know. So whether you use the Arduino computer or Raspberry Pi computer?
We're using Raspberry.
Yeah. So that
yeah.
that should be done. Yeah.
Yeah.
Okay.
So about the individual tasks that you mentioned, so we kind of, um, for now, me and Hamza are trying to be more on the software side of it, and Hassan and Ibrahim are more on the hardware side of it. But as for next presentation, how do you want us to? I know you talked about it a few times. How do you want us to present it to you? You want us to say, like Mohammed researched about MIT App Inventor, and this is the progress, like that individual report?
Right. So for example, yeah, the Hamza look at the whatever like system programs and then what are the like if they present us some block diagram, you just cut and paste the block diagram, and then these are the software components in it, and these are the interfaces. You don't need to present the even very detailed source code, no, but I think some ideas and also some of the materials, useful materials
Right.
Okay.
Right. Yeah. We
to
will
show.
do that next
So it's
next time.
basically summarize what you have spent your time on.
Okay. Yeah.
Okay.
Sure.
Sure.
Okay. And then besides that, so we wanted to talk about the budget. Professor
sure.
Warren says we're allocated $250, but if we, with your approval, we can have it raised to 500. And
Oh.
I think
I
for
thought
our
it's originally 500. Oh, they try to control the.
The budget.
Oh, I see. So
Yeah.
okay, yeah. So let's see. So what is its estimation at the moment?
Yeah, I mean, well, one Raspberry Pi that we're estimating with about I think 8 GB of memory is already with, and I think that's with some extra components. That's already $175.
Yeah.
So that's
Oh, is it
already,
because of the high memories, right?
yeah, but I think it's
Yeah,
necessary
well,
because we're
fast.
not using our own computer. We're going to be relying solely on that. So I think that's necessary to have, which is already
So-
170.
Okay, so usually, you usually your computer, you partition whatever, and then you install Linux and you just try, from your notebook, and then you port the same thing over the Raspberry Pi. Of course, you can start with the Raspberry Pi itself, connecting your keyboard and whatever. I think that's so one Raspberry Pi is 180 something.
Yeah.
Yeah,
180,
after
yeah.
shipping and everything. Yeah.
Wow, that's a pretty high.
Yeah.
It's like $30 and $40. No, why?
Yeah.
Is it because of the memory?
Yeah.
Hassan.
Is it because?
Yeah, Professor, because because of the RAM is like it has like 8 GB RAM. Because we need to download Home Assistant. The Home Assistant is like big platform. So for that we need to buy like 8 GB RAM.
I see.
And that one also like more faster than other one because this is the new version is right now. The other one is too slow. Because I personally want to have Raspberry Pi 3. I mean, that was like taking like forever to download something. Yeah.
Yeah, but I think maybe it's good to control some the budget. So for example, if it's only for the downloading, I guess you can download to your PC and just connect dump on the like a memory, not RAM, but it's a RAM, right?
Yeah, it's a RAM.
Yeah.
Oh, okay. So that the package that you're using requires a certain amount of the memory, right?
Yes, Professor.
Okay, I see. All right. So in total, so what's your estimation?
Yeah, I mean, well,
Can you show? I think next page. I think.
No, we still have to do more research, like
Because we need
about the
yeah,
sensors and all the other components.
So we're
And,
already estimating like around 300 or so so far before we like add in all the components. But I mean, of course, we're trying to keep it under 500 and it should be under 500. But
Okay.
we definitely would not be able to make this work with 250. So we
Yeah,
wanted to.
We need to do more research on relay components.
Yeah, I think before I say yes, and I like to see like a list of the devices you're gonna buy, right?
So I mean, yeah, Professor, with like these 3 that we know for
Oh,
certain.
let me see. Okay, sorry that I cannot see.
Yeah,
Oh, you
there's
don't see my screen?
PCB
I think because
and
I use both the screen, and so let me see. Where is it? Where is it? I think I may. Oh, this one, right? Just a second. I think there's something. I cannot. I think it should be here. Why this one? Sure. Why is that? Just a second. Let me just turn back to the single screen. Oh, wasn't it in your the PowerPoint file, right?
Yeah, it's in my PowerPoint file.
Okay, so let me
Or it's in the power.
get there. Okay, I see. All right. Now I see that. So Android phone to use a controller, 60, 2 times the PCB, ESP, Raspberry Pi, need to search it. Okay,
So that's already over 250.
I see. Okay, so so should I send the email to him or what is it?
I mean, he wasn't clear about that, but I think yes, that would be the way. I mean, we can email him. I can email him and I can CC you.
Yeah. So say that I approve this the necessary increase beyond the 250.
okay.
Okay, and for that, do you know how it works? Do we buy the items ourselves and then we
Oh,
send
by
them?
the way, yeah, that's what usually is. So at the end of the semester, you have to keep all the receipts and it's going to be reimbursed.
Okay.
Okay.
So you you have to spend some money in
And
advance.
Professor, at the end of the semester, so do we have to keep the components?
No, it has to be, for ABET visits and others, it has to be kept at school.
Oh.
Okay.
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 Because school pays.
Okay.
Right, that makes sense. They own they own
If
they own the
you
project.
buy out of your money, you can make it 2, right, instead of 1. Then
We plan to make more models and not just one model. So yeah.
yeah, so if you make 2, then you just keep
Yeah,
one.
we don't. Ibrahim, you don't
Yeah,
need to worry. So yeah.
Yeah.
Okay.
You can donate one to college.
Oh, good. Good. All right. Okay. So again, yeah. So now I talk about this, so summarize and then upload it today and in 2 weeks, I guess. Next time, I think a little bit more detailed progress.
Oh yeah, we'll be detailed
Sure.
for sure. Yeah.
Yeah. Any other questions or issues?
Not so far.
Not so far.
Okay.
Yeah, if
All
we
right,
need
but
something, we
if you
can-
have any in the middle of 2 weeks, and just drop me an email, right?
So
Yes, Professor.
Professor Lee, our next meeting is in 2 weeks.
Yeah.
Okay, same time, everything.
But if you need a weekly meeting, I'm willing to do it. So just let me know.
Okay, Professor. Yeah.
I think so. This is a good amount of information to research, and I think this is good for 2 weeks. But we'll definitely ask any questions as necessary.
Yep.
Okay.
Thank you.
All right then. Thank you. See you.
Thank you,
Thank
Professor.
you. See you.
Bye. Yep. Bye.
Bye. Have a good one.
Bye.